This is a continuation of our discussion on integration by partial fractions. So we already discussed the different cases. Now let's take more examples. We solve some examples for case one and case two. So in this video, we will be discussing for case two and another one for case two and also for case three and case four. So let's take this example. X raised to 4 minus x cubed minus x minus 1 all over x cubed minus x squared dx. Let's take this one. Before you apply partial fractions or before you factor out the denominator, double check if the rational function is a proper or improper. Just like this example is an improper fraction because the numerator of the degree of the numerator is greater than the degree of the denominator. So what we do is we simply divide them first before we apply our partial fraction. So how do we divide this one? We can use long division. So x to the fourth minus x cubed minus x minus 1. Divide it with x cubed minus x squared. Then what will I multiply with x cubed minus x squared so that it will become x to the fourth? So I just multiply it with x. Then multiply x with x cubed minus x squared. So x times x cubed is x to the fourth. Then x minus x squared or times square, negative x squared is negative x cubed. Then we subtract. Then this will be 0. Then bring down. So this is minus x. Then minus 1. Then we cannot divide this one anymore with x cubed because the degree is less than the degree of the denominator. So therefore, x to the fourth minus x cubed minus x minus 1 all over x cubed minus x squared can be reduced into the form x, the quotient. Then we add the remainder, which is minus x minus 1, or we can just factor out that negative 1. Negative 1 here. Let's just make this minus x plus 1 all over x cubed minus x squared. So then here we can apply the partial fraction. We can distribute the integral. Integral of x is let's just x squared over 2. So we concentrate to the next term. The next term, x plus 1 x cubed minus x squared. We just need to integrate this one. But before we integrate, we solve the partial fraction. Then, so this is now a proper fraction. So how do we solve the partial fraction of this proper fraction here? The denominator is x cubed minus x squared. So first we need to factor that out. So this will be the same as x plus 1 all over, we can factor out x squared. Then we have x minus 1. Then from here, we can apply, this is case number 2, because it has a repeated root, x. So this will be a over x plus b over x squared. That's case 2. Then we just add the last case 1, x minus 1, c over x minus 1. And we need to find a, b, and c. So multiply both sides with x squared times x minus 1. So this will be x plus 1 equals a times x squared divided by x, then x minus 1 plus b, x squared will cancel out, so we just multiply it with x minus 1 plus x minus 1 will cancel out, so we just multiply it with x squared. Then we can use the first method by substituting values for x. So let x be equal to what? So what do we want to solve here? If we want to solve a, there's a common x minus 1, x minus 1. We cannot solve first for a, but we can let x first to be equal to 0 so that we can solve for b. So this will be 0 plus 1 equals a times 0, 0 minus 1 plus b times 0 minus 1 plus c times 0 squared. So this will be 0 and this will be 0. B times negative 1. So b will be equal to negative 1. Then next, after that, we can solve for c. So we can let x be equal to cancel out b or an a, we need to make x to be equal to 1. Then this will be 1 plus 1 equals a times 1, 1 minus 1, plus b times 1 minus 1, plus c times 1 squared. So this is 0, and this is also 0. So we have 2 equals c squared, or c is equal to 2. Then for a, we can substitute the values for b and c, and we can use any value for x. So let's use, we have already used 0 here and 1. We can use 2. X equals 2. Let x equals 2. So 2 plus 2 equals a. Our a is a known, times x, it's 2, times 2 minus 1. Then plus b, we already saw b, it's negative 1. Multiply it with x minus 1, x is 2, so 2 minus 1. Then plus c, c is 2. Multiply it with x, which is also 2, and you square that one. Then we can now solve for a. And a here will be equal to negative 2. So we already have the values for a, b, and c. So now, the integral of x plus, what's that, x plus 1, x plus 1 all over x cubed minus x squared, x cubed minus x squared. Or I just write the whole problem. So the problem now will be rewritten as integral of 1 or x plus this one x or minus x plus 1 over x cubed. So minus x plus 1 over x cubed minus x squared dx. But we already solved the partial fraction of that one. So this will be x minus our partial fraction, a over x. Our a is negative 2. So minus minus, so this will be plus 2 all over x. Then next will be b over x squared. Our b is negative 1 again, and negative negative, so this will be positive, still positive 1 over x squared. Then lastly for c, c over x minus 1, c is positive 2, so this should be minus 2 all over x minus 1 dx. Then we can now distribute the integral. So this will be integral of x dx plus 2 the integral of dx over x plus the integral of dx over x squared, then minus 2 the integral of dx over x minus 1. Then taking the integral of this now, what's the integral of x dx? It's just x squared over 2, or this is 1/2 x squared. Then plus the integral of the x over x is this ln, so this is 2 ln of x. then plus integral of dx over x squared. You already solved this one, d over u squared. You put x squared on the numerator, it will become negative 2. Negative 2, you add 1. Negative 2 plus 1 is negative 1. Then negative. So this should be minus. It should be minus. So this is minus 1 over x. Minus 1 over x, because the answer is x raised to negative 1, or that's 1 over x. Then minus here, let u equals x minus 1. So 2 ln of x minus 1, then plus c. Then we can, this is here and here, subtract, then apply the property of logarithm. So we can have 1/2 x squared minus 1 over x plus 2 ln of, so it's a subtraction minus, so we can make it a division. So this will be x over x minus 1 plus c. And this is now the integral of that problem. Okay, so this is still under case number 2. Now, if we go to the next example, case number 3. Let's try case number 3. Example, the integral of x cubed plus x squared plus x plus 2 all over plus 3x squared plus 2 dx. Okay, so first step, check if this is a proper integral, a proper fraction. Yes, it's a proper fraction because the numerator, the degree of numerator is less than the degree of the denominator. So we cannot divide, so we can directly apply partial fraction. What case is this? Before we determine the case is, first we need to factor out our denominator, x raised to 4 plus 3x squared plus 2. So how do we factor this one? Is it factorable? We can make this as x squared plus 3x squared plus 2. Then why do we need to put make that one as an x squared? We can let u be equal to x squared. So the equation will become u squared plus 3 times x squared, which is u, plus 2. Then look at this one, we can now simply factor these out. So u and u, factors of 2, 2, and 1. We add them, it should be positive 3, so 2, positive 2, positive 1. So therefore, the factors of 4x raised to 4 plus 3x squared plus 2 will be equal to u plus 2. Our u is x squared, so x squared plus 2. Multiply it with x squared plus 1. So if you look at the factors, this is not a linear factors. They are quadratic factors, x squared. So therefore, this falls either case 3 or 4. But the factors are distinct. It's not repeated factors. So this is now case number 3. So case 3, so x cubed plus x squared plus x plus 2 all over x to the 4th, this one, and we already factored that out, x squared plus 2 times x squared plus 1. Then using case number 3, so case number 3, we need to multiply a with x. Ax, this is in the form, this one, ax, then plus b. Then we divide it with, and the first one, x squared, or we can use plus 1, x squared plus 1. Then it's not repeated, it's distinct, so repeat the process again, but a, b, and can use c, or we can use a1. This is a1, and this is b1. Then we have a2 times x plus b2 all over x squared plus 2. And we need to determine a1, a2, b1, and b2. So as usual, we multiply both sides. We the denominator, so this will be x cubed plus x squared plus x plus 2 equals x squared plus 1 will cancel out. So a1 times x plus b1, we multiply this one with x squared plus 2. Then plus a2 x plus b2, you multiply this one with x squared plus 1. X squared plus 2 will cancel out. Then we can now apply our methods in determining the constants. And what should be the values for u? What should be the values for our x? In this example, if we look at x squared plus 2, what value for x should we substitute so that either one of them can be equal to 0? If I put negative 2, because this is plus 2, x squared plus 2, negative 2 squared still will not yield to 0. So any value for x here will result to not be equal to 0. So in other words, we cannot use that method. Whatever value you put, you cannot make the other term 0. So we have no choice but to use the second method, the method of equating coefficients. So before we use that, we need first to simplify our right hand side of the equation. So we need to multiply this and this, this and this, and so on. Okay, so a1 x times x squared. a1 x times x squared, this will be a1x cubed. a1x times 2, so plus 2a1x. Then plus b1 times x squared. Then plus 2 times b1. Then the other one, plus a2x times x squared again is x cubed. Plus a2x times 1. Then plus b2 times x squared. Then plus b2 times 1, or simply b2. Then rearrange. Let's rearrange the terms. X cubed plus x squared plus x plus 2 equals all the terms that has x cubed. What are the terms that has x cubed? We have a1, then a2, so plus a2. So those are the terms that has x cubed. Then how about the term that contains x squared? So plus x squared, we have b1 here. This is 2a1x. Then we have also b2. b2 times x squared. Then all the terms that contains x. We have 2a1, then we have plus a2, and multiply it with x. Then lastly, all the terms that are constant. So we have plus 2b1 and also plus b2. So okay, so we already arranged this. Then we can now inspect the coefficients. So first, all the coefficients of x cubed. To the left side, x cubed, what's the coefficient of that? That's equal to 1. To the right side, it's a1 plus a2. Coefficients of x squared. To the left side, we have also 1. And to the right side, we have b1 plus b2. 2. Then next, x raised to 1. To the left side, we have still 1. To the right side, we have 2a1 plus a2. Then lastly, for the constant x raised to 0, to the left side is 2. To the right side is 2b1 plus b2. Then we need to solve these 4 unknowns using these 4 equations. Let's call this equation 1, equation 2, equation 3, and equation 4. So we can work on equation 1 and 3 first. So from equation 1, we can derive the value for a1 is equal to negative a2. Then substitute this one to equation 3. So it will yield with 1 equals 2 times a1 plus a2 is, or a1 is negative a2. a1 is negative a2, then plus a2. Then we can now solve for a2. So this will be 1 equals negative 2a2 plus a2. Negative 2a2 plus a2, so a2 will be equal to 1 over or negative 1. a2 will be equal to, this equation here, a1 minus a, this should be, I forgot the 1 here. Should be a1 equals 1 minus a2. Should be a1 equals 1 minus a2. So we have 1 here and also 1 here. Then you multiply it by 2, so this should be 2. Then to solve for a2, so solving for a2, I just write this one. Let's do this again. A. So substituting a1 equals 1 minus a2 to equation 3. So 1, equation 3, 1 equals 2 times a1. a1 is 1 minus a2 and plus a2. 1 equals 2 minus 2a2 plus a2. Then 1 minus 2 equals negative 2a2 plus a2 is negative a2. And this is negative 1 equals negative a2. So therefore, a2 is just equal to 1. a2 is equal to 1. Then solve for a1. We can solve a1 using that equation. Equation 1 minus a2. a2 is 1. So a1 will be just equal to 0. The next, solving for b's using equation 2. From equation 2, we can also, it's like what we did, b1 will be equal to 1 minus b2. Then substitute this one to equation 4. And equation 4 is 2 equals 2 times b1. b1 is 1 minus b2. So it's the same with the first, the a's. And this will be 2 equals 2 minus 2b2 plus b2. Then we can cancel out 2. Here, this will be equal to 0. Then negative 2 plus 1, negative 2 plus 1 is negative 1. And this will be equal to 0 actually. b2 will be equal to 0. b2 will cancel out. It's 0. Then for b1, b1 is equal to 1 minus b2, so 1 minus 0. So b1 is just equal to 1. So we have now a2, a1, b2, and b1. a1 and b2 are 0, while a2 and b1 are 1. Then let's substitute this one to the problem here. So we will have, let's copy this one. Then substitute the values. So this will be the integral of x cubed plus x squared plus x plus 2 all over x squared times that one. That's x to the fourth plus 3x squared plus 2. 3x plus squared plus 2. Okay. Dx. This will be equal to the integral of the partial fraction, which is a1x. a1 is, again, a1 is 1. So, and b1 is, a1 is 0 and b1 is 1. So this will be 1 or all over x squared plus 1. Then plus a2 is 1. So this will be x plus b2 is 0 all over x squared plus 2 dx. Then we can now integrate, distribute the integral. This will be the integral of dx over x squared plus 1 plus the integral of x dx all over x squared plus 2. Okay? Now, the second term, we can directly integrate this one. Let u be equal to x squared plus 2. So that our du will be 2x dx. So we have a neutralizing factor of 1/2. And it will be d over u, so it's ln x squared plus 2. But the first term, this one, x dx over x squared plus 1. To solve this one, we use trigonometric substitution. Or we already discussed the additional formulas. From your problem set, you derive the formulas. And this is in the form, what's the integral of du over u squared plus a squared? From your problem set. So you already derived this one using trigonometric substitution. And the result will be tangent inverse. It will be equal to tangent inverse of u. This one, standard additional formula, du over u squared is equal to 1 over a tangent inverse of u over a plus c. 1 over a arctan u over a. So this is 1 over a arctan or tangent inverse of u over a plus c. So this is a derived formula. We already derived this one. We can directly use this one to solve this problem. So we can now integrate the integral now of x u plus x squared plus x plus 2 all over x to the fourth plus 3x squared plus 2 dx is now equal to the integral of this 1 over a. Our a is the square root of 1. It's just 1. So 1 tangent inverse of u, which is x over a. So just x. Arctan of x. Then plus the right side, we need a neutralizing factor 1/2. Why 1/2? Because the derivative of x squared plus 2 is 2x. So we need to multiply 1/2 to neutralize the problem. Ln, so 1 over u is ln over x squared plus 2 plus c. And this will be our final answer. Okay, so this is case number 3. Last example for case number 4. For case number 4. Okay, this is case number 4. Then if you look at the rational function, it's a proper fraction. Although it's x squared at the numerator, a denominator, it's still squared, and it will result to x raised to 4. So it's a proper fraction. So we can now, we don't need to factor out the denominator. We can already identify that this is in case 4 because it's quadratic and it's repeated square. So we just directly use case number 4, x 2x plus 3 all over x squared plus 1. So that is our factor, and it's quadratic and it's repeated, and this will be equal to, again, a1 times x plus b1 all over x squared plus 1. And what's next? Plus a2x plus b2. Then this is over x squared plus 1 squared. And that's case number 4. Then again, solve for a1, b1, a2, and b2. So cross multiply. 2x squared plus 3 is equal to a1x plus b1. Okay, multiply this one with x squared plus 1. Then plus, it will cancel out. So this is just e2x plus b2. Then determine the values for the constants. a1, b1, a2, b2. So here, again, we will be using the second method. So we need to simplify this. 2x squared plus 3 equals a1x times x squared. So this will be a1x cubed plus a1x times 1. So a1x, then plus b1x squared plus b1 times 1, b1, plus a2x plus b2. Then rearrange. a1x cubed, we only have 1. Then for x squared, we also have only 1. Then for x, we have 2 plus a1 plus a2 times x. Then our constants, b1 plus b2. This is 2x squared plus 3. Then, by inspection, x cubed to the left side, we don't have the term x cubed, so it's equal to 0. To the right side, we have a1. So a1 now will be equal to 0. Then x squared. To the left side, we have 2. That's the coefficient of x squared. To the right side, we have b1. So b1 is equal to 2. Then next, x raised to 1. To the right side, we don't have a term of x. So 0. To the left side, to the right side, we have a1 plus a2. Then lastly, x raised to 0, or the constant. So 3 is equal to b1 plus b2. So from the first two equations, a1 is equal to 0, b1 is equal to 2. Then using the third one, a2 will be also equal to 0. 0 equals 0 Then for b1 and b2, b1 is equal to 2. So 3 equals b1, which is equal to 2. This is 2. Then plus b2. Then solving for b2, b2 is equal to 3 minus 2, 1. So a1, 0. a1 is equal to 0. a2 is equal to 0. And b1 is equal to 2. And b2 is equal to 1. So the problem, we now can substitute that one. So the integral of 2x squared plus 3 all over x squared plus 1 squared dx is now equal to the integral of the first one, a1x plus b1. So a1 is 0. So this is just b1x. So, or b1, 2 all over x squared plus 1. Then for the next term, a2 is 0 plus b2. b2 is 1. So this is 1 over x squared plus 1. Then you square it again. dx. Then solve for this one. The integral of 2 over x squared plus 1 dx plus the integral of dx over x squared plus 1 squared. The first term, we can directly solve that one. It's just equal to the arctan 2 over a is 1. So 2 over 1, 2 tangent inverse of x squared plus 1, or x squared, or just x. Then the second term, we don't have a formula for this one, so we can only use the trigonometric substitution. So by Trigosolve. What case is this one? dx over x squared plus 1, x squared plus 1. It contains x squared plus 1. So we will be letting this one to be equal to x squared plus 1, the square root. Then what will be x and what will be 1? Where we'll be putting 1 and x, or x will be here and this will be 1. So if this is triangle, right triangle, what substitution we'll be using? So opposite and adjacent side, so it should be tangent. So tangent of theta is equal to the opposite side, which is x, divided by 1. So we can use this substitution, x equals tangent theta. Then what is dx? Then dx will be equal to, what's the derivative of a tangent? It will be equal to secant squared theta, d theta. So that's dx. Then we already have all what we need. Then we can now do the substitution. So dx, the integral of dx over x squared dx is secant squared theta, d theta, divided by x squared plus 1. X squared is tangent, x is tangent, so tangent squared. X squared plus 1. This is tangent squared theta plus 1, and this is actually equal to secant squared theta. So our denominator will be secant squared theta, then you square that one. Why square? Because x squared plus 1 squared. Then solve this. We can cancel out the 1 theta at the numerators, and this will be equal to the integral of d theta all over secant theta. Then what is 1 over secant theta? It's just equal to cosine theta. I forgot the square. So this will be cosine squared theta d theta. And what's the integral of cosine squared d theta? What's the identity for cosine squared? Cosine squared is equal to 1/2 plus what? 1/2 plus 1/2 sine 2 theta times d theta. Then what's the integral of this? 1/2 integral of 1/2 is just 1/2 theta. So this is 1/2 theta. Then plus integral of 1/2 sine 2 theta. There's a 2 here. Neutralizing factor 1/2. So this will be 1/4 integral of sine. This should be cosine. This is wrong. It should be cosine 2 theta, so that our answer will be sine 2 theta. Then plus c. Then what is theta and what is sine 2 theta? X is equal to tangent theta. And if you want to solve for sine 2 theta, what is sine 2 theta? Tangent theta is equal to x. So if we want to solve for theta, so tangent theta is equal to x. So theta will be equal to tangent inverse of x. How about sine 2 theta? Sine. So sine here is sine 2 theta is equal to 2 sine theta, the identity of sine 2 theta. Sine 2 theta is equal to 2 sine theta times cosine theta. Then what is sine theta? If you look at the triangle, sine, so opposite over hypotenuse, this will be equal to x over the square root of x squared plus 1. Then for cosine theta is adjacent side, which is 1 over the hypotenuse, x squared plus 1. Then if you multiply them to solve for sine 2 theta, sine 2 theta is equal to 2 times sine theta x over the square root of x squared plus 1. Then you multiply it with the cosine 1 over the square root of x squared plus 1. Then this will be 2x all over square root. The square root will cancel out. This will be x squared plus 1. So that will be sine 2 theta, and we need to multiply it by 1/4. So 1/4 sine 2 theta, 1/4 sine 2 theta will be equal to 2 over 4. It's 1/2. So 1/2 x all over x squared plus 1. Then we put this together. So we have now the integral of 2x squared plus 3 all over x squared plus 1 squared dx. This is now equal to the first one. We go back here. 2 dx over x squared plus 1. So using the formula, u squared du over u squared plus a, it's just equal to 1 over a tangent inverse of u over a. So this will be 2 tangent inverse of u over a over u is x. So tangent inverse of x, or arctan x, then plus this one 1/2 theta, or theta is this one, so it should be 1/2 tangent inverse of x. Then for the 1/4, this is the answer for the 1/4, so we just add plus 1/2 x all over x squared plus 1, and plus c. We can add these two because they're the same, tangent, so we can add them. So the integral now 2x squared plus 3 all over x squared plus 1 squared dx now will be equal to 2 plus 1/2 is just equal to 5 over 2. Then tangent inverse of x. Then plus that one 1/2 x, or we can put the 2 at the denominator, 2 over x squared plus 1 plus c. And this will be the result of our integral. And this is under case number 4. Okay, so this is integration by partial fraction. Our next topic will be rationalizing substitution, and that will be the last method that we will be discussing in chapter